everybody. I'm Dan Furman. I'm chair of the Department of Electrical and Computer Engineering here at Michigan Tech. And we're here to recognize and thank one of Michigan Tech's long-standing industrial partners, Ford Motor Company, for their generosity and for their support of our missions in education and research. I'd like to welcome Glenn Ross. He's president of Michigan Tech, and other members of the administration that are here. I don't know if there's anyone here, but if anyone from the Board of Control, Tech Fund Board of Trustees, Presidential Council of Alumni, welcome. I'd like to extend a special welcome to Dave House. He's a member of our ECE Academy and an electric vehicle enthusiast himself and leader of our Generations of Discovery capital campaign that we're celebrating this week. And also a warm welcome to all Michigan Tech faculty, staff, and students that have chosen to join us this afternoon. So good to see everybody. It's my special pleasure to welcome and introduce Birgit Sorgenfrey of the Ford Motor Company. Birgit is a member of the ECE Academy, having graduated from Michigan Tech with a degree in electrical engineering in 1993. She also holds an MS in electrical engineering from MIT and an MBA with high distinction from the Ross School of Business at the University of Michigan. She began with Ford in 1994 after internships with General Motors, GE Medical Systems, IBM, Schlumberger, and the University of Hanover. She's moved through a number of engineering research and development positions at Ford and currently is the Global Material Cost Manager for powertrain installations. Did I get that right? Yeah. Okay. As a Michigan Tech student, Birgit participated in symphonic and concert bands and choir and varsity tennis, and as an alumna, she's a member of the McNair Society and the Presidential Council of Alumni. She's active in the Society of Women Engineers and served as the president of the Detroit chapter in 1998 and was named SWE's Distinguished New Engineer in 2000. As always, we are happy and proud to welcome her back to campus. Birgit Sorgenfrey.
The Ford Motor Company is proud of the long-standing relationship with Michigan Tech, offering more than $2 million of sponsorship in the last 3 years alone, and hiring thousands of graduates over the last 60 years. As a tech graduate, like many alumni, I value my tech experiences, which prepare graduates for professional success. Tech alumni are an industry-leading teams which deliver American-made products, great American-made products, like the Ford Escape Hybrid, which was the first American-made hybrid. Michigan Tech offers innovative and crazy smart educational opportunities. So Glenn, on behalf of the Ford Motor Company, I'm happy to donate this 2012 Ford Focus battery electric vehicle to prepare future electrification engineers.
Thank you so much. He goes back many, many years. It goes back to a time when floorboards were boards, when dashboards were boards, and where headliners were probably made out of who knows what. But Henry Ford was a pioneer, really, in so many of the things he did, and especially in the integrated marketing of his products and the integrated manufacture of his products. One of the gifts the Ford Motor Company gave to Michigan Tech at one time was the town of Alberta and 1,600 acres of forest land back in 1954. This is Henry's 150th birthday, and normally, you give somebody a birthday present when it's their birthday. In this case, we're getting the birthday present back. And from the time when floorboards were boards to the time where cars are electric, this has just been a fantastic partnership with the Ford Motor Company. So thank you so very much. And Dan, I think these are yours.
All right. Thanks, Glenn. This is a happy day for Michigan Tech and the Department of Electrical and Computer Engineering. And I believe this gift says a lot about the role of electrical and computer engineers in the automobiles of yesterday and today and tomorrow. So with your indulgence, I want to take a couple of moments just to reflect on that history. And Glenn's already referred to it. In the beginning, automobiles were almost 100% mechanical, right? They converted stored energy from fossil fuels into kinetic energy. And I say almost 100% because they actually did have spark ignition initially, which was electrical. But actually, if you think about it, you don't really need that, right? Diesel engines worked without a spark. And then initially, cars were almost 100% mechanical, and they started by hand cranking, right? Which required physical strength and a certain amount of good luck, I imagine. So now eventually, cars were introduced with electric motors, electric starting motors, I should say, and a battery to operate it. thus relieving certain athletic requirements on the driver. This electrical source in turn also made possible the addition of certain safety features like lights in the front and lights in the back and little lights that would blink on and off and windshield wipers so you could drive in the rain. These electric headlights were a big improvement over their predecessors, which depended on either candles or kerosene or something like that. Now, having cars that were easy to start, or relatively easy to start and relatively safe to drive was one big improvement, but also doing something about the boredom of long distance driving was another, so eventually entertainment systems were added, starting with the radio and then cassette players and an 8-track tape and then CD players and so forth. Now I'm dating myself a little bit by bringing up the 8-track tape, but when I was in high school, if you had a car with an 8-track tape player, you had it going on, okay? But electricity also played a role in the comfort, right, and for the heating and the controls for the heating and the air conditioner as well. And then in the 60s and 70s, and with the NASA missions to the moon, we had the advent of microelectronics and microprocessors and the possibility of electronic controls in automobile engines. So now prior to that period, the bulk of the control was accomplished through mechanical sensors and actuators, which were actually quite ingenious, but were limited in their tolerances and their flexibility. So with electronic controls, you have the advantage of increased flexibility as well as programmability, and thus the era of computer or computer-like control of everything from timing to fuel injection from transmission was born. Of course, this increased the complexity of the engine as well, so look at a modern car and try to get a wrench in there sometime. In more recent times, we see that communication capabilities of cars have expanded. Car radios or small aftermarket devices can receive GPS signals and help the driver with navigation. And of course, if you have a radio capable of receiving signals, then you can also transmit signals. And so now we have the era of cars communicating with a home office or some central national location. So a personal watershed moment for me, and some of you have heard this story before, it's like one of those moments where you say, Toto, we're not in Kansas anymore. It was the day that my 90-year-old father got an email that said it was time to change the oil on his Buick LeSabre, which was just astounding to him, and it was astounding to me at the time as well. But that's the way it works now. And so if you can communicate with a centralized facility like that, then cars can communicate with each other as well. And so now we see a lot of interest in ad hoc vehicular networks. And while we're at it, what the heck? Let's just go ahead and put a full-up computer in the car and give the driver all of the capabilities that they have with tablets or smartphones, and let's create the sort of networks that those devices enable. And in fact, what's happening now is that the automobiles of tomorrow are going to be the most prominent nodes on the networks of tomorrow in what's being called the Internet of Things. Okay, and of course that begs the question, if you have a car with all this computational capability, communication, navigational capability, who needs a driver, right? So the era of autonomous vehicles is upon us as well, and it's something that's really fired up the imagination of a lot of young engineers. Now, all these developments that I just mentioned, you might call the electricity of information or small signals, but I've left out the one, really the biggest part of this, which is the electrification on the big signal side. Okay, that is the conversion of the powertrain from the internal combustion engine to an electric motor or hybrids of the two. Now, the viability of this technology and its acceptance by the consuming public is still very much an area of active research and debate, but it's a great question to be explored, and all the major automakers are looking at it, including Ford, as we can clearly see here today. And with that change, we see a complete transformation of the automobile from 100 years ago to today. Powertrain, controls, communication, climate control, entertainment. As of today, as Dave House has pointed out to me, the automobile has evolved into nothing more or nothing less than a big rolling computer. So, and one other point I want to make is that in parallel with all these advances in the automobile itself are the advances in the factories that make them. For every engineer that's adding some cool feature or even something that's completely revolutionizing the automobile, you need another engineer who's going to help you figure out how to make it. Okay? That's a fact that we're becoming aware of here at Michigan Tech, and I'm sure it's not lost on Ford either. So, the point of this long-winded story is to let you know that the need for electrical and computer engineers, and therefore the opportunities for electrical and computer engineers in the automotive industry, have never been greater. Michigan Tech recognizes this, Ford recognizes this, and this gift that we're thanking them for today is a strong statement about what Ford is doing to cultivate the next generation of engineers who are going to help them create and sell automobiles. I think Michigan Tech, with its long association with Detroit, is in a really great position to be a player in this arena. And for that reason, I hope our relationship with Ford remains strong, and I'm sure that it will. Our students and our graduates have the talent, the aptitude, and perhaps most importantly, the inclination to work on technology like this. So we're extremely grateful to Ford for this gift, which is going to go a long way toward helping us realize that vision. And at this point, I want to turn the floor and these keys over to John Lukowski, our ECE faculty member and co-advisor for the hybrid electric vehicle enterprise, our joint enterprise with our good friends over in mechanical engineering mechanics, our plans for using this gift. John?
Well, maybe you really don't want to know the plans. There's lots of students from the hybrid electric vehicle enterprise and from the automotive computing enterprise, and everybody wants to drive the vehicle, number one. But then almost everybody else, they want to dissect it and find out what makes this thing tick. And so maybe you don't want to know too much about that. I want to say this is a really exciting day, for myself and for Bob Page, who is my counterpart and co-advisor in the hybrid electric vehicle enterprise. We're in the throes right now trying to put together a proposal to enter EcoCart 3, which is a hybrid vehicle competition with other peer universities. And this is where the exciting part is, because there are lots of other institutions that have programs that with extensive modeling and simulation, and whether their strengths are in modeling machines or components or systems or an overall vehicle performance. It is only the best universities, however, that have physical laboratories where they can validate their simulations. This is going to be our physical laboratory right here. So we can do our modeling, we can do our simulation, and then what we can do is we can go in here and provide an opportunity for students to go out and instrument and measure, and then get out and tweak and modify and optimize, and then as guided by their simulations, and be able to validate what they're really doing. And this is where I feel that our Michigan Tech students really excel. They're not afraid to step out from behind their keyboard and go into the toolbox, pick up a wrench, and start working on a vehicle. And it's these hands-on experiences in these emerging, and this is certainly a rapidly evolving technology, that makes our programs here at Michigan Tech unique, and I believe world-class. Of course, these opportunities are only available by having strong partnerships with our industrial partners. And that's why I'd really like to take the opportunity to thank Ford Motor Company, especially Birgit, for her hard work, Pete in corporate relations and our advancement officers, to getting all the players together and making this donation possible. So thank you very much.